Okay, returning to our science journey. So now we know perfectly well that we are living in the Milky Way galaxy and we are one in billions of these star systems in the galaxy. And if somebody one out there is interested, they can meet us in the Orion arm of the galaxy. That's our address. So that was our current address, but we know our history that 13.8 billion years ago, from nothing, a singularity, this universe was born. And after 400 million afterwards, the galaxy starting its shape, taking its shape. Our galaxy is a spiral kind of galaxy. There are three kinds of galaxies by their shape. And our galaxy is spiral. We are on the Orion spiral. And about 8 billion afterwards, that is about 5 billion years before today, estimated, our solar system started taking its shape. And it's estimated that it's likely to last for another 5 billion. So in that terms, we can say it's a sort of a project with a beginning and with an end. And there's a very interesting project lesson that things go in a very designed and phased form, from a solar nebula to protostars to planetesimals, and then mass started getting attracted by the force of gravity. Gravity is the cause of space. If there's no gravity, everything would have scattered equally, like as if we throw like a sand and it's equally distributed, sort of. But the gravity started making lumps. Where does the space come from, or why space exists? Is the gravity is the answer. And then protoplanets, which turned into the planets, and uh, that is how if it could be created in 3 minutes, and next split second they could have taken the final shape as well. But that's probably a life lesson, that things go in design phases. From the school system, again connecting ourselves, we had no clue that the sun is also moving. Probably it was written in some of the books that the sun is stationary, earth is moving. And our books were definitely outdated. Even then, it was known. 20 years before, it was known. It was known much earlier. The sun is moving in this interesting shape, up and down, and oscillating shape around the center of the galaxy. The beautiful journey it has, and its speed is tremendous, 230 kilometer per second, which is more than 800,000 kilometers per hour. And obviously, the galaxy is huge, and the sun is somewhere in the middle. It takes sun about so many years, 230 million years to take one cycle, and 20 cycles obviously have been completed. Just divide 5 billion by 230 million years, which one cycle takes, and you will get 21 something. So 20 years completed, and galactic years, and we are into the 21st year, so not very old really. And about 20 more years will go and the sun will die. When sun goes up, it actually comes down by the gravitational force of the center of the galaxy, which tries to pull it down, but it goes down, and that continues, and then it goes a little bit down, right? Then it attracted back to the center. So that's how, and it's a beautiful spiral. It should have been kind of displayed, 'cause that's how it's moving. But our somehow the school systems were not meant to inspire. That's the purpose, that it's inspiring. As Quran says, kullun fi falakin yasbahun, all heavenly bodies are floating in their orbits. A bit of anatomy is that the first four planets are terrestrial planets. They have a sort of surface, a rocky surface. They have high density. And after that, the planets are very rare. They are gaseous planets. So they are called Jovian planets. Jovian means like Jupiter. And our Earth has a natural satellite called moon. Natural satellites are called moons. Many of them have moons. Jupiter has many, probably 70 or something. The total 194 natural satellites are there. And these symbols, which are very interesting, these have been adopted by NASA to represent planets, and this is the symbol for the sun as well. So sun is the head of the family, and it's taking all of the its 8 children and so many 190 something plus moons around it. So obviously, it is the big one which has enough gravity to attract them and keep all of the planets around us and even our bodies and all that. So, in 99.85% of the total mass of the solar system is the sun itself. So very little is left actually for the Earth, and the rest of it is asteroids and meteoroids and interplanetary small rocks, and there are some belts also we will see in a while. And if I am talking or my sound box is moving or you are moving your eyeballs, we are getting energy from where? From food. And food is came from where? From plants or animals. And eventually, all energy come from plants. And those plants get energy from where? They get energy from the photons coming from the sun. And that energy is stored in the chemical bonds. We'll understand more. Our cars are moving, they are consuming hydrocarbons or natural gas or even electricity. Eventually, hydrocarbons are carbohydrates. Hydrocarbons are again fossils, and they're plants, and they got once their energy from the sun, and that were preserved in their chemical bonds. So all energy that we are talking and using and walking is coming from this energy ball, this fireball sun. So that's great. One question always was used to come to my mind, and maybe many others, that planets move like in different orbitals, or they are like a plate, and our orbitals are on the same plane. Because the picture of the atom that we see looks like the above picture, right? Actually, we got the idea of the orbits of the atom, which is now a nonsense idea. We moved out, and we now think it's not like that. But those were like the upper picture. And what's your idea? Planets are like the lower picture moving, or they are like the upper picture? Interestingly, everything is well designed, right? If they have been moving in different planes, the balance was obviously very precarious and difficult to maintain. So nature, the creator, knows how best ergonomically to keep things. And even the overall universe also looks like this sort of plane, but hugely big and hugely uh, uh, thick as well. But this plane, solar system plane, is called ecliptic plane, where we get the word eclipse. So all these planets, except Pluto, are on this ecliptic plane, beautifully moving. And you see there are planets, and in the middle there is an asteroid belt. And there is an asteroid belt on the outer side also, which is a Kuiper belt. The farthest thing in the solar system is Oort cloud, and that's about more than 100,000 astronomical unit. One astronomical unit is Earth Sun's average distance, 150 million kilometers. So that is how the side view looks like. Now I share a very interesting a couple of stories about how maths, which is just the abstract things, made in human beings so much powerful. This asteroid belt, which is inside, was not discovered by our satellites and cameras or our electromagnetic waves. No, a mathematician named Bode, when he saw the distances of these planets from sun and just mapped it as it looks like in the table, he discovered a pattern in them. And in this pattern, he found there is something missing after Mars, and there at 2.8 astronomical units, there should have been something. He said, I can't see it, but the pattern shows something should have been created here. In his view, it should have been planet. But later, decades later, more than 50 years later, we discovered that there was an asteroid belt and its gravity is felt like the planet. So that's the beauty of the math. Likewise, a French mathematician, Leverrier, he discovered Neptune just from the perturbation of the Uranus and Saturn they were putting. And he thought, if this planet is getting disturbance, there's some gravitational forces are coming from somewhere. And that's how he discovered that some planet must exist over there to cause disturbance on the Uranus moon, probably. And the same evening, when they saw over there, they found the planet was there. Amazing. I mean, human being, the mind, the maths is amazing. So that's the story, the briefest story. We are getting energy from the sun. All we are moving or talking or doing our works and projects. Solar system itself is a project. Sun will collapse after 5 billion years, we estimate. That's how it's happening, and we are very tiny. There shouldn't be any space for the hubris, right? So let's be grateful to sun or the one who created the sun. Think about it. Thank you.